How well do we know our cars? Pretty well, as it turns out. From their form to their sounds. We knew them as our home away from home. But how well do our cars know us? This is not a question we could answer. Until now. It's been a while since the last milestone, but technology is reigniting our story as a true partner in our evolution. It's intelligence empowered by a common understanding. It's automation shielding us from the unexpected. It's connectivity, broadening what's possible. The car has never failed to inspire us, but as we spend more time together, it will grow to truly understand us, knowing what moves us, protecting us under any circumstance, anticipating our curiosities, and sparking our imaginations. More than a machine, it will become our friend, car and driver. What was once an unspoken bond will now progress on new grounds of mutual affection. Together, we've come a long way, so let's keep going.
Ladies and gentlemen, please welcome Senior Vice President Automotive Operations, Toyota Motor Sales, Bob Carter.
Good afternoon, everyone. I'm so happy to welcome you here to the 2017 Consumer Electronics Show. But before I begin and tell you about what we brought to this year's show, I'd like to acknowledge and welcome a very important executive for all of us, our Senior Managing Officer, all the way from Toyota Motor Corporation in Japan, Mr. Tomiyama. Tomiyama-san, great to see you. Now, I wouldn't be doing my job if I didn't take just a few minutes of your time to talk about the industry sales results that just closed last evening. The industry ended with the best ever December in the history of the U.S. automobile industry, with an annualized rate of 17.5 million sales, exceeding 2015, and provided the 7th consecutive year of growth in the U.S. But most notably, we've seen the car-truck mix move from 50-50 to about 37-63 over just the last 3 years, which really demonstrates that this movement of consumer preference to SUVs and trucks is real and sustaining. Toyota Motor sales sold 2.45 million vehicles in 2016 in the US. The brand was the #1 retail brand for the 5th consecutive year, and it was our 15th consecutive year where Camry was the #1 selling vehicle in America. And our Lexus brand had a terrific year in its 2nd best year in its 27-year history. So, okay, let's get on to it. Toyota has an amazing floor display this year over at the Convention Center that we're really proud of. You're going to get a first look at our next generation telematics system that we call Entune 3.0. We're also showing off the Smart Device Link, and it's our new platform for app developers to be able to connect smartphones and vehicles. So I would encourage everyone, as you have a few minutes over the next couple of days, to please stop by our booth and take a look. But today we're going to do something a bit different. We're going to introduce you to a really special concept vehicle. And we're going to tell you why we believe it's so special. Because all of this talk about advances in automotive technology, it's really easy to lose sight of why we build cars. We make them for people. And at Toyota, we think the most important question isn't whether vehicles of the future will be equipped with automated or connected technologies. Of course they will. But the most important question is this: what is the relationship, what will the relationship be like between those new vehicles of the future and the people who use them? Will that relationship be cold, robotic, sterile, tool-like? Are we going to be building just technology on wheels and nothing more? Or can technology be warm and friendly, engaging, immersive, because cars have always done more than just get us from point A to point B. Cars have become our home on wheels, and we connect with our cars. We build an emotional relationship, and thanks to the research into advanced artificial intelligence, we think the future of the automobile is a vehicle that connects with us. So, ladies and gentlemen, it is my pleasure to introduce to you the advanced artificial intelligence system we call Yui. Now, Yui learns from us, grows with us, builds a relationship that's meaningful and emotional. Now, what does that mean? Yui learns our preferences and our lifestyle and remembers where we like to go, pays attention to whether we're happy or sad, and helps in ways that are both big and small while anticipating our needs and improving our life. So Yui, what are you still doing up on the screen? Why don't you come down and show everybody our new amazing car? So what do you think? Isn't this a gorgeous car? Say hello to the Toyota Concept-I. I want to recognize and congratulate a few people. First, our Caldy Studio Chief Engineer, Ian Cartabiano. Ian, welcome. As well as the rest of our Caldy design team that worked on this beautiful car, as well as our Chief Engineer, Akabi. Akabi-san, thank you for joining us. They've done some amazing work to bring this car to life. But there's more to it than just a pretty face. The Caldy team developed a concept that we're calling kinetic warmth. It's a design philosophy that's guided every element of the Concept-I's creation, beginning with artificial intelligence. Now, it follows our belief that the vehicle of the future should not start with just technology. It should start with the experience of the people who use it. And so we built the Concept-I from the inside out, focusing on making it immersive, warm, and energetic. With a user experience assistance from the Toyota Innovation Hub in San Francisco, the interior is designed to help support that user experience. Now, you'll notice lines flow from the center of the dashboard throughout the vehicle, and Yui can travel around them using light, sound, and even touch to communicate critical information. There's an amazing 3D heads-up display to help keep the driver's eyes, and most importantly, their attention to the road. But information also appears like magic on the dashboard, on the walls, on the seats, wherever you need it, whenever you need it. Even the exterior of the vehicle is about building a relationship between the car and the world around it, communicating with others on the road while expressing motion and excitement and even a little bit of magic. But this is not just a design story. Now, for years, we at Toyota said that we need to look beyond simple driver-vehicle interface and focus on the driver-vehicle relationship. Now, thanks to Yui, the Concept-I is built to enhance that relationship. This is a vehicle that grows with you. The more you drive, the smarter Yui gets. It learns to anticipate your needs And that intelligence is it's more than about just planning your next route. Yui uses sophisticated biometric systems to monitor the driver's attention and emotions, and can help determine when to trade off control of the vehicle between automated and manual driving, depending on the conditions. With Yui and Concept-I, the car and the driver, well, they become as one, as teammates. And this is a team that I know I'm going to want to be part of because it's just fun. Concept-I is kinetic, it's exciting, and it's passionate. And thanks to the Concept-I advanced automated driving technologies, it's a car that people with all levels of ability are going to be able to experience. And that's what it all comes back to. Using technology to help people in ways, whether it's big or small, whether they're in or outside of cars. Now, this Concept-I isn't going to be on the road tomorrow, but we still have an awful lot of work to do. But guess what, folks? We will be evaluating many of the Concept-I's features and technologies on the road in Japan within just the next few years. And I, for one, I can't wait. So now it's my pleasure to introduce someone who can tell you much more about what we're doing to make this amazing vision of the future a reality. Please welcome our CEO of the Toyota Research Institute, Dr. Gill Pratt. Gill?
Thank you, wonderful. Thank you very much, Bob, and thank you, Yui. Good afternoon, everybody, and welcome again to the press conference. This is the one-year anniversary of the Toyota Research Institute. Our job is to explore emerging opportunities, to identify gaps in research, and to move in new directions. Now, sometimes we find dead ends as well, but we always move quickly to explore great ideas. In the 1 year of our existence, we've assembled an incredible team. We've hired more than 100 people. We've added 50 more people from Toyota Motor Corporation, and our plans are to hire another 100 people this coming year. TRI's mission is focused on artificial intelligence. It includes 4 goals. First, we're dedicated to greatly enhancing vehicle safety, and someday creating a car that is incapable of causing a crash, regardless of the abilities of the driver. Second, our goal is to greatly increase mobility access for those who presently cannot drive. Third, we plan to heavily invest in robotics to move people not only across town, but also within their home from room to room and help them to age in place. And finally, we have a goal to accelerate discovery in material science by applying techniques from artificial intelligence and machine learning. Now, research is our middle name, and it's what we do. Much of it, but not all of it, with Stanford in Palo Alto, California, with the University of Michigan in Ann Arbor, and with MIT in Cambridge, Massachusetts. We recently opened, in fact, in Massachusetts, our permanent facility that you see over here. Now, before we go any further, I need to remind you that I used to be a professor. And of course, once you're a professor, you're always a professor. And so I always enjoyed, of course, the process of doing research, but I also love to give lectures. And so I'm giving you a lecture today, and there's even going to be a short test towards the end of the remarks to see how you do. Actually, more seriously, my remarks today reflect on findings from a few key research projects that we've been engaged with, both ourselves and our partners over this past year. It's framing a question that is specifically designed to offer us clarity and to provoke a discussion throughout the industry of just how complicated this business of autonomous mobility really is. This question that I'd like to discuss with you today is as follows: how safe is safe enough? Society tolerates a lot of human error. We are, after all, only human, but we expect machines to be much better than us. Last year, there were about 35,000 fatalities on US highways involving vehicles that were controlled by human drivers. Every single one of those deaths is a terrible tragedy. So what if we could create a fully autonomous car that was as safe on average as a human driver? Would that be safe enough? In other words, would we accept 35,000 traffic fatalities in the US at the hands of a machine instead of a person? Would we accept it if it resulted in greater convenience, in less traffic, and less impact on the environment, but the number of fatalities was the same? Now, rationally, perhaps you'd think the answer should be yes. But emotionally, would we accept it from a machine? We at TRI don't think that it's likely that being as safe as a human being is actually an acceptable standard. So let me progress. What if the machine was twice as safe as a human-driven car? If 17,500 lives were lost in the US every year at the hands of a machine, would we accept this kind of autonomy? Emotionally, we don't think so. Historically, human beings have shown nearly zero tolerance for injury or death caused by flaws inside of a machine. And yet we know, as wonderful as artificial intelligence is, artificial intelligence systems are inevitably flawed. And the ones that our autonomous cars will depend on are presently and unavoidably imperfect. So again, I ask the question, how safe is safe enough? I know that in the very near future, this question will need to be answered. And we don't yet know for sure what that answer is. It's not even clear how that standard will be devised and by whom. Will the standard be local, or will it be the same everywhere in the world? It's a very hard question. So let me shift to a standard where we actually do have some answers. It's SAE International J3016. It was revised just last September, and it defines 5 levels of automation. I want to review this standard with you in a typical university lecture, because there continues to be a lot of confusion within the media about it. And I think it's important that everyone really have a common vocabulary and understand it. All car makers are aiming to achieve level 5 autonomy. In level 5 autonomy, the car can drive fully autonomously under any traffic or weather condition at any place and at any time. No human being required. I need to make it perfectly clear. It's a wonderful, wonderful goal. But none of us in the automobile or IT industries are close to achieving true level 5 autonomy. We are not even close. And collectively, our current prototype autonomous cars can handle many situations, but there are still many others that are beyond current machine competence. And it's going to take many years of machine learning and many more miles than anyone has logged, both in simulated and real-world testing, to achieve the perfection that's required for level 5 autonomy. Luckily, there's good news, because SAE defined not only level 5, but level 4. And level 4 is almost as good as level 5, but it turns out that it will have a much shorter timetable for arrival. Level 4 is a fully autonomous car that only works in specific operational design domains. An example of such a domain is M-City, which is a test facility that exists near the University of Michigan and that we and other car manufacturers use as a test site. We can design at that test site various restrictions to test level 4. It could include limited areas of operation, limited speeds, limited times of the day, limited weather, any one of those things. So when it comes to company A or company B or company T saying that it hopes to have autonomous vehicles on the road by the early 2020s, it's level 4 that's the technology that is probably being referred to. TRI believes it's very likely that a number of manufacturers will have level 4 autonomous systems operating in specific locations within a decade. And level 4 autonomy will be especially attractive and adaptable for companies that offer mobility as a service, because ride sharing and car sharing and inner city last mile models match up and may well offer the best application for bringing level 4 to the market sooner. Moving down the ladder, let's look at level 3. Again, to make sure that we're all sharing the same vocabulary. Level 3 is a lot like level 4, but with an autonomous mode that at times may need to hand off control to a human driver who may not be paying attention at the time. Handoff, of course, is the operative term and a difficult challenge. In level 3, as defined by the SAE, the autonomy must ensure that if it needs to hand off control of the car, it will give the driver sufficient warning. Additionally, level 3 must also ensure that it will always detect any condition that requires such a handoff, because in level 3, the driver is allowed to disengage and is not required to oversee the autonomy. Instead, they may engage fully in other tasks, like reading a book, checking your email, looking at your phone. The term that SAE uses when a vehicle system can't handle a particular dynamic driving task is a request to intervene. And so the challenge lies in how long it takes for a human driver to disengage from texting or from reading once the autonomy requests this kind of a fallback. It also depends on whether the autonomy system can absolutely ensure that it will never miss a situation where a handoff is required. Now, considerable research shows that the longer a driver is disengaged from the task of driving, the longer it takes for that driver to reorient and get back into driving. Furthermore, at 65 miles an hour, a car travels around 100 feet every second. That's a long distance. It means that to give a disengaged driver, let's say 15 seconds of warning, at that speed, the system has to spot trouble 1,500 feet away, or around 5 football fields ahead. That's an extremely hard guarantee for a level 3 system to provide, and it's very difficult to achieve. Now, regardless of the speed, a lot can happen in 15 seconds. So picking that as a time to reorient a driver, ensuring that is very, very difficult. And it means that it may even be possible that level 3 is as difficult to accomplish as level 4. So let me, again, by way of sharing our vocabulary, bring us down to level 2. Level 2 is perhaps the most controversial right now because it's already here, it's already functioning in some cars on public roads. In level 2, a vehicle handoff to a human driver can occur at any time with only a second or two of warning. It means the human driver must be able to react mentally and physically at a moment's notice. Even more challenging is the requirement for the level 2 human driver to always supervise the operation of the autonomy, taking over control when the autonomy fails to see danger ahead. If you want to understand level 2, you must remember that drivers must always monitor the autonomy, sort of like tapping on the brake to disengage adaptive cruise control when we, as a driver, see debris in the road that the adaptive cruise control sensor doesn't detect. This will happen in level 2 systems, and we must never forget it. Human nature, not surprisingly, remains one of our biggest concerns at TRI. There are indications that many drivers may either undertrust or overtrust a system. When someone overtrusts a level 2 system's capabilities, they may mentally disconnect their attention from the driving environment and wrongly assume that level 2 systems are more capable than they actually are. We at TRI worry that overtrust can accumulate over many miles of hands-free driving at level 2. And paradoxically, the less frequent the handoffs occur, the worse the tendency to overtrust may become. There's also evidence that some drivers may deliberately test the system's limits. They essentially may misuse the autonomy in a way that it was not intended to be used. So we need to think a lot about situational awareness and mental attention. It turns out that maintaining this kind of awareness that's required while engaged in monitoring tasks has been well studied for 70 years. Research psychologists call this the vigilance decrement. The research started during World War II, when it became clear that radar operators looking for enemy movement became less effective as their shift wore on, even if they kept their eyes on the task. So in 1948, a research psychologist named Norman Mackworth wrote a seminal paper. It was called The Breakdown of Vigilance During Prolonged Visual Search. The experiment that he performed used a clock that he devised that only had a second hand, except that the second hand would occasionally and randomly jump by 2 seconds instead of 1. So it turns out that even if you keep your eyes on the clock, on the Mackworth clock, this graph here shows that over 2 hours of time, your performance at detecting these 2-second jumps will decrease in proportion to how long you do it. So as I promised you at the beginning, we're going to give you a test. It's a 20-second long test that I warned you you were going to have, but it's not too long, so let's see how it goes. I want you to watch the second hand of this clock here, which just like Mackworth did, every time the hand bumps by 2 seconds, instead of 1 second, I want you to clap your hands. So we'll have you do the Mackworth test. You ready? Here we go. Wow, that was pretty good. Let's see if we can detect it even better. All right, excellent. You guys did great. You all get A's. But let me ask you a question where I think you might not get an A. How do you think you'd do if you had to do that task for 2 hours? Not so good. And going back to cars, how about being given the task to remain vigilant, supervising the autonomy, ready for a possible handoff at a moment's notice for level 2 autonomy over 2 hours? Pretty tough. So does this kind of evidence, which has been going on since the 1940s as a research study program, mean that level 2 autonomy is a bad idea? There are some companies that have already decided that the challenges may be too difficult, and they've decided to skip levels 2 and 3. We're not sure. It turns out that we're finding some evidence that certain activities, and this does not include texting, so please don't misunderstand, seem to reduce the vigilance decrement over time. We're actually finding that some mild secondary tasks may actually help to maintain situational awareness despite time going on. For example, think about long-haul truck drivers. They have extremely good safety records comparatively, and you have to ask yourself, how do they do it? Well, perhaps it's because they employ mild secondary tasks to help them keep vigilant. They talk on two-way radios. They scan the road ahead. We know, of course, they look for speed traps. Well, almost all of us, when we've had a long car trip, have listened to the radio, perhaps as a way of staying alert during a long drive. Now, if you talk to safety experts that have studied this, there are divided opinions over whether doing that kind of secondary task is a good idea or a bad idea. Now, as Bob said earlier, the human-machine interface and the human-car relationships are extremely important to Toyota. We at TRI continue to explore this issue, and we're continuing to try to find answers. So we don't know. But what we do know for sure is that as we move forward towards the ultimate goal of full autonomy, what is most important is to strive to save as many lives as possible in the process, not just at the end. Because it's going to take decades to have a significant portion of the US car fleet functioning at level 4 and above. And so for that reason, as I've spoken about for quite some time now, TRI is taking a two-track approach. We're simultaneously developing a system that we call Guardian, which is designed to make human driving safer, while simultaneously we are working on levels 2 through level 5 in a system that we call Chauffeur. Much of the work in hardware and software that we're developing to achieve Chauffeur is also applicable to Guardian and vice versa. In fact, the perception and the planning software that's in the Guardian and Chauffeur systems that we're working on are basically the same. And so the difference is that Guardian only engages when it's needed, while Chauffeur engages all of the time whenever the autonomy is turned on. This video here demonstrates an early prototype of our Guardian simulator, which we have at our temporary facility in Palo Alto. I'm very happy to say that we're now working on a new, highly advanced simulator, which we're going to show off soon, in our new permanent facility in Palo Alto that we're currently in the process of moving into. So to understand Guardian, you can think about anti-lock brakes, vehicle stability control, automatic emergency braking as early forms of Guardian. But the Guardian that we're thinking about goes beyond that. And when it arrives, it'll be a hands on the wheel, eyes on the road, only when needed system that merges human and vehicle situational awareness. The Guardian driver is meant to be in control of the car at all times, except in the cases where the Guardian anticipates or identifies a pending incident and briefly employs some kind of corrective response. Depending on the situation, Guardian can alert the driver with visual cues, with audible alarms, and then, if necessary, influence or control speed and steering the same way that a chauffeur would do, but only temporarily. Like Yui, the Concept-I agent, Guardian employs artificial intelligence. And like Yui, the plan is for Guardian to become smarter and smarter through both first-hand data gathering experience and intelligence that is shared via the cloud. Over time, we expect Guardian's growing intelligence will allow it to sense things more clearly and more quickly process and more quickly anticipate a wide array of situations on the road. Now, every year, cars get safer. One reason is because every year, automakers equip vehicles with higher and higher levels of both active and passive safety. In ever-increasing numbers, with active safety, vehicles are already being entrusted to sense a problem, to choose a course of action, and then to respond, assuming for a brief period control of the vehicle. Which brings me back to Concept-I and how we think about it at TRI. At TRI, we think that Yui, the Concept-I agent, might not only be a way to engage with human beings and provide useful advice to the driver. We think it might also be a way to modulate and maintain a driver's situational awareness using mild secondary tasks to promote safety. We've only begun this research to find out exactly how that would work. Perhaps, for example, Yui could engage the driver in a conversation that would reduce the vigilance decrement the way talking on the two-way radio or even looking for speed traps seems to do with truck drivers. We think that the agent might be even more effective because Yui would be coupled to the autonomy system in the car, which would be constantly monitoring the car's environment, both inside and out, merging human and vehicle situational awareness. We're not sure, but at TRI, we're aiming to find out. Now, Toyota is involved in many aspects of making future cars safer and more accessible. Yui and Concept-I is a small part of that work, but it has the potential for becoming more than a helpful friend. It has the potential for becoming the kind of friend that looks out for you and keeps you safe. It has the potential to become a guardian as well as a chauffeur. And so our goal at TRI is to someday create a car that will be never be responsible for causing a crash, whether it's being driven by a human being or being driven by a computer. Concept-I, in summary, may become a key part of that plan. Thank you very much.